Hi, this is the screencast to describe our process model. Um, I will go through the entire model very quickly at first. Afterwards, I will go through the entire model again in detail while also going along in the simulation here. We modeled a potential way to set dynamic prices for a taxi service or a ride-sharing service. And this is how we did it. It starts with a user task where we request the starting position of maybe a potential customer, and we use their starting position to call a service. The service checks whether they are within or outside our operating area. So we call a bounce, we call this bounce service, and then we check if they are outside of our operating area. Maybe they are too far uh, outside of town. Maybe they are trying to call a taxi in Zurich, and we only drive in St. Gallen. Then we send a rejection. If they are starting within a within our bounds, then we continue on with the process. Once we continue on, we want to call 3 more services. Before we can call the distance service, we need to know where the customer wants to go to, so we need their destination. We ask it again in a user form here, and we then take all the responses and put it into a decision table, which finds the markup. So the decision table is here. And of course, we know from experience and through common sense that if it is raining or if people are traveling in busy hours, they tend to be willing to pay more. And if they are traveling very short distances, they might want to pay more. Of course, it's also important to know that if they're traveling very far distances, we might charge them a little less. And we also include a base price, which makes the calculation easier. So the base price is just the normal price if none of these factors are considered. So after having found the markup, we have a last user task where the markup and the base price is shown to a human. This might be done for different reasons. I will come back to that at the end. So let's do a simulation. All right, so I start the process here, assignment 2. We have no business key that we put in, and we start with the origin request. This is actually quite foolproof because it's a service we build ourselves, which in the background uses a Google Maps API, and we can put in relatively readable information. So instead of putting in an exact address or coordinates, we basically put in maybe we're at Haskell, and that's where we want to start our ride. Click complete, which then sends the request to the service immediately. This is of course here. Haskell is within our bounds, so we immediately go on to the destination request, and this is here. So we want to know the destination. Let's say I want to travel to Zurich. I click complete, and I get confirm price as the next task immediately. In the meantime, we have called 3 services, gone into the decision table. The decision table has found the markup, and now we are showing what the markup actually is. So I'm traveling quite a far distance, which means that I get 10% off basically, 20% off actually. I'm traveling more than 5 kilometers, and I'm also traveling more than 20 kilometers. Right now it is within the busy hours of 16 and 20 o'clock. So we add 25 to the markup, we remove 20, and we are left with 5 as shown here. And we have a we set a base price, which was relatively arbitrarily chosen. Um, and this base price can be changed here as well. So after having received the request and the destination from the customer, we have a base price. I might want to change the base price for some reason. I might want to change the markup. And this is why we included the last user task here. We find this is actually quite important. In certain situations, a taxi service might want to artificially increase their markup. They might want to say, actually, all rides cost 50% more. Maybe there's an important game in town, a football game, or maybe there's a different event. Maybe they are seeing more demand than they are used to, and they would increase their markup. Maybe they want to reduce the markup to the base price, basically. This might be done in a disaster relief situation. So if there's a storm or if there's some emergency in the city, a taxi service would look quite bad if they charged high prices, even though demand was very high. So they might choose to only make their base price because of publicity reasons. We are going to go with the original 0.5. So this is a 5% increase basically. And once we complete, the process is done and we have completed this price request and sent on the price requested by the customer. Now, of course, we can do an example where we are not within bounds. So the path that we took right now was this. We went here and exited here. Now let's try to get an outside of bounds. So let's say I want to drive back from Zurich. I just drove to Zurich. With this taxi service, I want to go back. So instead of starting at Haskell, we start in Zurich. And after I complete, this again sends the bounds request, and I get this, a rejection message. And this would basically be a message shown to the customer. There are many steps within this process that could be customer facing. So the origins request would obviously be possibly customer facing, the rejection message, as well as the destination request. In Camunda, we model these as user tasks. But of course, if you open an app, for example, like Uber, these are done by the customer, not by a user inside of the company. And this rejection message would also be shown as maybe an error message within the app. And I can complete this, basically accept the error message, and this is where we exited our second simulation. I think that was it.